Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tebang Mapozani. This lesson is brought to you by the Lutheran Cape Department of Education in collaboration with Bagama Research and Development. Now, grade 12, in today's lesson, we are preparing ourselves for our prelim examination, and we are going to look at the second part of our revision, where we are going to look at the topic of functions and graphs, and we are also going to look at finance, growth, and decay. Now, grade 12, by the end of this lesson, you should be able to identify the structure of paper 1, and we are going to focus on the following topics. Number 1, the first topic that we are going to focus in for this lesson or on for this lesson is functions and graph. The second topic, we are going to look at finance, growth, and decay. Now, this is our structure we are having for paper 1, and we are saying to you, paper 1, it has around 6 topics, and we are going to focus on the functions and graph. And the topic of functions and graph weighs 23% of our paper. That is, it is allocated around 35 marks in our paper 1, and it is mostly found in question 4 and 5. So it occupies 2 questions. So for some papers, it might be slightly different, but it's around those questions. And the second topic we are also going to focus on for this revision is finance, growth, and decay. And this topic, it weighs 10% of our paper. And the marks allocated for this topic in our paper 1, it is 15 marks. And it is mostly found in question 6. So finance, growth, and decay, it occupies only 1 question from our paper 1. Now, grade 12, we have a question paper in front of us. So we are going to focus on question 4 September 2024. And for this activity, grade 12, you are given 15 minutes to complete this activity. And your 15 minutes countdown starts now. Welcome back, grade 12. Now, let us look at question 4. Question 4 goes as follows. Given the functions defined by f at x is equals to negative 2 over x minus 1. By virtue of just looking at the function given there, you must be able to identify whether it's hyperbola, it's parabola, it's exponential, or it's linear. If we can see, this is a standard form for hyperbola, because we remember that our hyperbola standard form, it goes as follows: is a over x plus p plus q. So we can see it's a over x plus p, and we can see that it's only x below, meaning our p was supposed to be how much? 0, and plus q, and our q is going to be negative 1. And we are given another function which goes as follows: it is g at x, it's equals to k to the power x. This function is an exponential function, as it takes the format of an exponential function. So that is the function that we are having right there. So we are going to just write the standard for exponential. We can see there is no p, means it was 0, and q was also 0. So it's a times b to the power x. Then they said we have a point which is 1:3 that lies on G. Now let us look at 4.1. So 4.1 says determine the value of k. Where is the value of k? The value of k is denoted nicely in my g at x. And we are told that there's a point that lies on G. And that point is 1 and 3. Now to find a, what we are going to see is, we are going to say as k lies on g at x, we are going to substitute the point 1:3. And I only substitute the point 1:3 given that we are told that this point lies on G. So to find the values of a or k, a or b in a standard, or a k in this case, which is representing a or b in this case, we are now saying to you, we're going to substitute a point that lies on this graph. Then when we do that, we can see our x value is 1, our y is going to be 3. Then k to the power 1 is k, then k is equals to 3. Let us look at 4.2. 4.2 reads as follows: write down the equations of the asymptotes of f. Let us go back to our standard of this f. Remember, we said our f gives us a hyperbola, and the standard of a hyperbola, it is a over x plus p plus q. Right. Now the equations of the asymptote, we are going to start by looking at the horizontal asymptote. And when we are looking at that, or let's start with the vertical asymptote. When you look at the vertical asymptote, we can see that our P there, it's not shown here. That means our P is equals to 0. Then we can see our Q already. Our Q is going to be what? Our Q is going to be -1. Then our asymptotes, the first asymptote is going to be x equals to P. Then x equals to P, this is just going to be x equals to 0 because P is our 0. Then our second one is y equals to Q. Then our y is equals to -1. Remember, it's x equals to -P in this case. Yes. Right. Then let us now check it. So our asymptotes are x equals to 0 and y is equals to -1. Looking at 4.3, 4.3, it says to us, write down the equation of g to the power -1, which is the inverse of g. So we're looking for the equation of the inverse of g. We know that our g, it was g at x equals to 3 to the power x. Our k was 3. Then we're going to write it in a y format to say y is equal to 3 to the power x. Then from here, to find the inverse, we're going to swap x and y. So we can see that our x will go where y was and our y will go where x was. That's what we're having. Now we're going to have x equals to 3 to the power y. Then to get the inverse, we're going to make y the subject of the formula. And to do that, we're going to introduce a log. We know that if we are given y is equal to a to the power x, then we know in terms of logarithmic, this will now become my y. It will become a base. And this will become the what? The argument. And here, this will be the subject of formula. So in this case, we are going to have the log. Our base is going to be a. Then our argument is y is equals to x. Same applies here. Then we can now see that our 3 is going to be our base. And this one is going to be our argument. And that is our y is going to be the subject of the formula. And we are having it right there. Then we can conclude and say, therefore, for our inverse, it's equals to log base 3x. Now let us look at 4.4. 4.4 is as follows. Determine the x-intercept of f. Now to find the x-intercept, we know we are going to say from our f at x, our x-intercept, we let y to be 0. Then x-intercept, whenever we see y, we are going to place in 0 at that position. Then we're going to solve for x. We can transpose the 1 to the right hand side. Then we have -2 on top. Then we can cross multiply. When we cross multiply, 1 times x is x. Then x is going to be -2. Then we're going to 4.5. 4.5 says, draw the sketches of f and the inverse of g on the same side of axis and clearly indicating all the asymptotes, the intercept with the x-axis. The first thing that we're going to do is the following. The first thing we're going to now check, we are looking for the points of interest. What are the points of interest? Points of interest, they actually told us it is actually our intercept and our asymptotes, including the turning points if we are having any. Those are the points of interest. Let's start by the inverse. When you look at our inverse, we are going to have to find our intercept. Then we can say our x-intercept, we let y equals to 0. Then where there is y, we're going to say 0. It's equals to log base 3x. Then we are going to now solve for x. When we solve for x, we are going to reverse the log. It's going to be 3 to the power 0. Then x equals to 1. Then our x-intercept is 1 and 0. Then we are going to check for y-intercept. When you say the y-intercept, let x equals to 0 here. We are going to have y is equals to log the base of 0. And this log base of 0, you will notice as you punch your calculators, it becomes, or it gives us what you call a math error. Meaning to us, we do not have a y-intercept. Meaning our y equals to 0 is going to be our asymptote. So there's no intercept there. As a result, it becomes the asymptote. Now let us look at the point of interest for f at x. Now the point of interest for f at x are as follows. We are going to have f at x, we're going to say the x-intercept. We already calculated the x-intercept in the previous question. And we have them, it was -2 and 0. and we already had the asymptote was y was -1 and the x was 0. Now let us populate this in our sketch. We can start with our inverse. We see that our x-intercept is at 1 and 0, and we are now seeing that it goes and continues to that, and we are proceeding and looking for f at x, which is our hyperbola. It is -2, so our a is negative. When a is negative, which is less than 0, we know that our graph must lie on the second and the fourth quadrant. That is where our graphs will lie. Then our asymptote is x equals to 0. Then we are going to say y x equals to 0. That is the line we are going to have them. And our y is equals to -1. So those are the asymptotes for our f at x. So that is the graph that we are having right there. Now grade 12, we are having 4.6 and 4.7, and for these two questions, grade 12, you are given 8 minutes to complete these two activities, and your 8 minutes starts now. Right, now grade 12, welcome back. Let us now discuss the solutions for 4.6. 4.6, it says, for which values of the axis of symmetry of f has the negative gradient with the, for the which values of x will the axis of symmetry of f, which has a negative gradient, intersect with the graph of x. So we just want to know which points, or we can just say values of x, but we are looking for points whereby the axis of symmetry will intersect, or the one that has a negative gradient will intersect with the graph of h. Remember, when the two equations or the two graphs intersect, we are going to use a simultaneous. So what are we supposed to do here? We are supposed to take the equation for the axis of symmetry, and we are going to equate it with the f at x. Then that is where we're going to find the point of intersection between the axis of symmetry with the negative gradient and our f at x. Now let us go through this one. So the first thing that we're now supposed to do is to find the axis of symmetry of our f at x. So we want to know where that axis of symmetry and the negative, actually let me just try to draw them. Remember, our function was like this. So we want to know why at this point whereby this axis of symmetry, it is now intersecting with the axis of symmetry with the negative, it is intersecting with our f at x. So this is our f at x, and that is the axis of symmetry. We want to know its interceptions. Right, now we know that our p is equals to 0 from f at x, and our q is already -1. This is our q, and p, because it was supposed to be plus p, and shows that there is no value, so it means it was x plus 0 at the bottom. Then we're going to substitute the values of x, of p, and our q. Then our x of symmetry with a negative gradient is negative x minus 1. Thereafter, to find the point of intersection, we are going to say equate the f at x and the axis of symmetry equation. That is going to give us the point of intersection. Right, when we equate the two equations, we solve for x. Then what we do here, we can transpose the 1 to the right hand side. It becomes +1, then the 1 and the 1 will subtract out. We have, so from here, what we had was the following. We had -2 over x, then we had it's equals to -x minus 1 plus 1. Then 1 plus 1, and they will do what? They will now subtract out. From here, we can cross multiply. Then we can say x times -x, we get -x squared. It's equals to -2. That is what we are going to have in this case. Right. Then when you proceed, we can now divide by -1. We can divide by this one longer root, so we can just divide by -1. Again, even if we have x and the x here, they will subtract out because x is going to be positive this side, then we'll subtract out. Then x squared is +2. Then we're going to introduce the root. Then our x values are actually, x is +√2. So this is the point here. It's x is equals to +√2, and this one is on the negative x-axis, going to be x is equals to -√2. 2. So those are the values of x. The two are going to intersect. Now, let us look at number 4.7. 4.7 says, consider the graph h, where h at x is found by saying g to the power -1 into x plus 2. We are going to say now, determine the values of x for which the g at x into x plus 2, it has 1, it is less than 1. So in this case, we are going to look at our function to the inverse of g at x. And when we are looking at that function of g at x, we notice that it says x plus 2. So we found that h by shifting the inverse of g 2 units to the left. So it goes to 0, and it's gonna be at somewhere at -1. And even the asymptote here will go 2 units. It's going to go to the -2. So that asymptote, it will now exist there. Then we can now see that our function, it's going to be somewhere at that point. Now, so which values of x will be less than 1? So 1 must be somewhere on the y-axis. So we just have to go and find where 1 is. Is this intersecting at 1 or not? So that's what the other thing that we need to check. Now, let us now find the values. And x can be -2. So we are now saying to you, if 1 is somewhere here, everything on the left hand side, we can see they will be below 1 in this case. So if it is below 1, that means all of these values this side are valid until the asymptote. So that's why we're saying x starts from the negative asymptote until here. So it's from the -2 until the 0. We are still below 1. Now, if we go further and extend on this question, because we have our log 3 into x plus 2. So that is our h in this case. So if we go and check our y-intercept where x equals to 0, when you place the 0 there, we find that our y-intercept is at somewhere at this point, which is 0,6. That is where our y-intercept is. So 1 is above that point of intersection. Right. Now let us check again. If 1 or this point here, it is still below 1 or it's above 1. So if I have my log 3 and I have x, I substitute x is 1 plus 2. I want to know the y value corresponding to this x value. Then I find that my y, so let me just rewrite this so that it looks clearer. So we said y is equals to the log of 3. Then I substitute 1 in the space of x. Then what am I going to have? I have y, it's equals to 1. So this point exactly corresponds to how much? To 1. So that is the point 1 here, when x is 1 and y is equals to 1 in that case. Then we can now see that our 1 is also included because it's saying it must be equal to or less than 1. So our line 1, as it passes them, it also takes in our value of 1 in that case. So x exists between -2 and straight to 1 because those values are below that line 1. Now, grade 12, let us move on to question 5. Our question 5 were from 5.1 until 5.3. And for these 3 questions, you are given 10 minutes to complete this activity, and your 10 minutes starts now. Welcome back, grade 12s. Now let us look at question 5. Now question 5 reads as follows. And before we can read the question 5 again, we must be able to relate to our sketch on the right hand side and see if we can analyze the sketch without having to go through the questions yet. Let's see. A, it is our y-x-intercept for both graphs, and that's where both graphs are meeting. So A is 2 things. A is giving us what? Number 1 is giving us the y-intercept for f and for g, and it also gives us the point of intersections of the 2 graphs. So we have spoiled for choices. If we're looking for A, we can use the intercept of x for f, or we can find the intercept of x for g, or we can equate the 2 to find A. Then we're going to proceed and see C is our turning point for f, so we know how to find C. We are going to work with our turning point. And our turning point, remember, we are going to work with the differential, or we are going to use the axis of symmetry with our standard form there. Right. Then we proceed. Our B is the x-intercept again for f. So to find B, we are going to utilize the x-intercept y equals to 0. Then our T, it is another point of intersection between G and f at x. So T is another point of intersection. Right. Let us now go to the statement and see what the statement says. The sketch shows the graphs of the function f at x is equal to negative x squared minus x plus 12. And the graph g at x is equal to x plus 4. A and B are the x-intercepts of f. Okay, we have already established that. And we are told that while C is the turning point of f, okay, and the functions intersect at A and T. So we have already established all of these points. Now let us go to 5.1. 5.1 says determine the x coordinates of A and B. We already said A and B are our x-intercept of f. Then how do we find A and B? We are now going to say from our f at x, we have the equation of the f at x. We are going to say our x-intercept, because A and B are the x-intercept, y equals to 0. Then we substitute y equals to 0. Then what we do from here, we can divide by negative 1 throughout, so that we have our standard form where our x squared is a coefficient of positive 1. Then when we do that, we have our x squared plus x minus 12 is equal to 0. That is a nice standard form. We can factorize the left hand side. When we do factorize the left hand side, we get our first bracket is going to be x plus 4, and our second bracket is x minus 3 is equal to 0. Then our x is equals to negative 4 from the first bracket, and from the second bracket we get our x to be 3. So that means therefore the x coordinate of A, because it's on the negative side, it's going to be negative 4. Then the x coordinate of B is going to be 3 because it's on the positive side. Now those coordinates are A is going to be 0 is to negative 4 is to 0, and B is going to be 3 is to 0, because B it lies on the positive side, so it will take the positive value there. Determine the range of f at x. What is a range? Let's go back there. Our range, we remember, it is a set of y values where our function is found. Where is our function found? Our function is found from C, the turning point, when I'm looking at the set of y values going down to the infinity. So how do we find the range of this graph? So to find the range of this graph, I just need to know what is that turning point of C, and because that's where our graph exists, it exists from the y turning point of C going down. So to find that range, I'm going to start by saying, okay, I want to find my turning point of C. To find the coordinates of turning points, we use the axis of symmetry and say x equals to negative b over 2a. Then we know that our standard form, it was already given as it is ax squared plus bx plus c. We know that our a is going to be negative 1 from f at x. So our a equals to negative 1. Then our b, we can see is going to be negative 1. Okay. B is also negative 1. Then our c is going to be positive 12. We're going to substitute in our values. Are going to be negative b, which is negative 1, or b, which is negative 1 over 2 into a. Then our a is negative 1 also. Then our x coordinate is negative 1 over 2. Thereafter, to find the corresponding y value, we are going to substitute our negative 1 over 2 in our original f at x. When we do that, we are going to say whenever there is x, I substitute in my values of negative 1 over 2, which is x. Then I get my y equals to 49 over 4. Then the coordinates of C are negative 1 over 2 and 49 over 4. Remember, we're looking for the range. So range is concerned with our set of y values. So it is from that 49 over 4 going down. So y must be less than or equals to 49 over 4. Less than or equals to 49 over 4. From that 49 over 4, because 49 over 4 is the turning point, that is our graph still exists at 49 over 4 going down. Right. Determine the value of k at x is equals to 3 to the power f at x minus 12. So to find the maximum value of this k at x, we are going to find the maximum value at where our f at x is at its maximum, right? Because we can see that the k at x, it is produced from that f at x to the power 3 to the power f at x minus 12. So to find that maximum value, we are going to say the maximum value for f at x, the highest value we can find for f at x, it's going to be at 49/4, which is the turning point. Then we're going to substitute f at x into the k at x. Then we can find that our k at x is going to be 3 to the power 0.25. Then our k at x is going to be 1.32. Then our maximum value for the k at x is going to be 1.32. Now grade 12, let us proceed, and we are going to look at question 5. And for question 5, we have 5.4 and 5.5. For these two questions, you are given only 5 minutes to complete these two activities, and your 5 minutes starts now. Welcome back, grade 12 learners. Let us now look at our 5.4. 5.4 reads as follows: determine for which values of x multiplied by f at x is going to be greater than 0. So we are going to look for the values of x when I multiply my x and my f at x. It's going to give me a value that is now greater than 0. Then how do we now find that? We are looking for the points whereby x is already positive. To get greater than 0, we must have the positive on the f at x. Now the positive values are, we can start by that one and say from here, from 0 to 3, our f at x is positive, and from that value 0 to 3, it now works and say 0, it's less than x, it's less than 3. So that is the first point that satisfies our condition. Then the second part, remember we are looking at where our x is, our y is positive, because we need to be f at x must be positive. So y is positive here, here it becomes negative, here after this y becomes negative, so it's also positive there. So it is also found between -4 and 0. You can see that f at x there, it is now positive. So this will be incorrect for this solution. So we are going to say the second solution is found between -4 and x and our 0. So that's why f at x is positive. Remember, this says x is already positive, so I multiply the positive x and a certain value, which is y, must be giving us a positive answer. So you look at the sign. Signs are negative, and negative must give me positive. But it's x already positive. As x is already positive, that means the only condition I have is to say positive and positive to get a positive value. So that is why we are going to have our solutions. Our solutions are 0 and 3. 0, x is less than 3 and is greater than 0, or x is greater than 1 over -4 and less than 0. Now let's look at 5.5. 5.5 reads as follows: for which real values of k will x to the power -x squared plus minus x plus 12 is equals to k have two negative unequal roots. What are we looking at? We are looking for which values of k will our f at x is equals to k have two negative unequal real roots. So where are we having that situation? In this case, we can now look at what we call line k. What is line k? Line k is going to be the line that gives us two negative unequal roots. So k, it's going to be the line that gives us two negative unequal roots. So that line, we can see that it's going to be, we're going to look at the turning point, and we are going to check that line is touching the x-axis. This is my line, twice at that point, and there we are going to have negative roots right there. But if we can check, if the line is drawn somewhere here, we are going to have a negative root and a positive root. Do I want that? No, we want two negative roots. So that means our line k can only move between the y-intercept of f, which is 12, and also move from the turning point, which is 49. So between the turning point, which is 49/4, and the 12, that is the only parts whereby our line K will give us two negative roots that are unequal. After 12, we're going to see that our K is going to give me a negative and a positive, which is what I'm not looking for. So our answer now, it will lie between K must be less than 49/4 and it must be greater than the 12 right there. So which is those 2 points that we are having in that case. So it's from the 12 until the 49/4. Now grade 12, let us move on to our question 6. And for these two questions, grade 12s, you will be given 12 minutes to complete these activities, and your 12 minutes starts now. Welcome back, grade 12s. Now let us look at question 6.1 and 6.2. Now 6.1 goes as follows. The value of the vehicle worth 150,000. So question 6, as you can see, we are looking at finance, growth, and annuities. So we are looking at financial mathematics. So what are we going to say now? We are told that the value of a vehicle worth 150,000 differentiates at 13% per annum. Calculate the value of the vehicle 6 years if the depreciation is calculated on the reducing balance method. Remember, this is finance. Finance, first thing that you're supposed to do, collect the data. So we are told that the vehicle is worth 150,000. So the present value, it's 150,000, because that is the worth of that vehicle. It's our present value. Our depreciation rate, I, is going to be 0.13 per annum. Calculate the value of the vehicle. So you want the value of the future value of the vehicle after 6 years. So our N is going to be 6. We are using the reducing balance method. So we go to our formula sheet, we quote down our formula from the formula sheet of the reducing balance method, where A is equals to P into 1 minus I, all raised to the power N. Then we put in our values. Our A, we are looking for A. Our P is 150,000. Our I is 0.13. Our N is equal to 6 if we have stated them. Then punch everything in our calculator. Then the value of the car is going to be 65,043.93 rand. Now let's look at 6.2. 6.2, it goes as follows. A loan of 300,000 is taken out at an interest of 5.3% per annum, compounded quarterly. The loan was taken out on the 1st of March 2016. The first payment was made on the 1st of December 2016, and it is to be paid in 72 equal payments. Then the first question reads as follows. What is the outstanding balance on the loan on the 1st of September 2016? So we are going to look at for the outstanding balance on the 1st of September 2016. Now let us go back to the statement and collect the data. Remember, finance, you must be able to read the statement more than once. Now, we are told that the loan of 300,000, so the present value, it is our 300,000, right, is taken out at an interest of 0.053. All over, it is compounded quarterly. So we are going to say all over 4. And we are told that the loan was taken out on the 1st of March 2016. And the first payment was made on the 1st of December. This is interesting now. Right. So from the 1st of March to December, here we're going to have a deferred annuity here. We haven't paid anything. So what are we looking at here? We are looking at the deferred annuity. We have postponed the payment. So we have paid the loan on the 1st of December. Let us just draw a very basic timeline for this. I'm going to start by this. When I think of my basic timeline, I see at my T0, I'm going to say this is the 1st of March. And I am going to look at the quarterly payments. So the first quarterly payment that was supposed to be made, it is from March, April, May, and June. Right. So from T0 to T1, which is going to be the 1st of June. So that is the first period. So go to the 1st of June. And so the 1st of June, it is our first quarter. Then the second quarter is going to be June, July, August. Then 1st of September. So that's going to be our T2. Right. Then we are going to proceed our T2. It is at the 1st of September. So this is the 1st of September. Then T3, let's come to T3. It's going to be September, October, and November. Then the 1st of December will be our T3. So the 1st of December, it is our T3. So what do we see here? We deferred a payment from T0 to T3. Right, and we want to know what is the outstanding balance of the loan on the 1st of September 2016. Remember, here there's no payment. Now, in a situation whereby there's no payment, we know that the money will still grow. For how long? From T0 to T1 to T2. So our N in this case is going to be 2 for us to find the outstanding balance on the 1st of September. Right, so now our N in this case, we are going to get it as 2. So as our N is equals to 2, we can now work around this. Remember, we said our P, it was 300,000. Our I was 0.00053 over 4. Then our N is equals to 2. Then we want to know what is the outstanding balance on the 1st of September. So we are going to look at the compound growth, because for now we haven't made any payment, so the money was gaining interest on its own. So A is equals to P into 1 plus I raised to the power N. So we are adding interest from 1 March to 1 September. How many periods are these? It is going to be 2 quarters. Because remember, it was quarterly. So it was 2 quarters as we've introduced with our timeline. Then we're going to place in our values. Our P is 300,000, our I is 0.053 over 4, and our N is equals to 2. Remember, those are the 2 quarters we didn't make any payments. Then the outstanding balance on the 1st of September 2016 is now 308,002.67. Now, determine the quarterly payments required to pay back the loan. How do we get our quarterly payments now? Now, the first thing, remember, you need to remember this. Our P, it is now, let us go back and get our P. It's 3,008 and 02. So our P, 3,008 and 002,16. I'm just gonna see that as we proceed. Oh yeah, 08 and 002,67. That's going to be our P. Then we know that our N, they said going to be 72 equal payments from that December. So then our N is going to be 72, and we are looking for our X. Our I is still the same, which is 0.053 over 4. Remember, we are now saying our present value is no longer 300,000, because the loan gained interest whenever we're not making any payments. So our new present value on the 1st of December, we are going to be 300,000 and 8,002. Right, we're going to substitute in our present value of an annuity. Then we get our X. We divide everything. You can see we cross multiply first. When we cross multiply, we get 300,000, 308,000 and 2. Multiply by, so we cross multiply this over 1, multiply our denominator, which is I 0.053 over 4, then we divide by everything here, then our X will become our monthly repayment is going to be 6,664,20. Now, grade 12, let us look at question 6.3. And for this question 6.3, you are given 8 minutes to complete this activity, and your 8 minutes starts now. Thank you for joining me on this lesson. See you on the next lesson.